Welcome. Today, we're going to unlock some really powerful shortcuts in algebra. And trust me, these aren't just boring rules from a textbook. They're tools that can basically turn you into a mental math wizard, making seemingly tough calculations, well, pretty simple. All right, let's just jump right in with a challenge. Have a look at this problem. Without a calculator, what's 2022 squared minus 2021 squared? Now, you could try to do that by hand, but that sounds pretty tedious, right? What if I told you there's a super elegant way to solve this in like under 10 seconds? Yep, stick with me and we'll figure it out together. So, to crack that puzzle, you really don't need a machine. What you need is the right toolkit, a calculator you can build right inside your head, and that's exactly what this next part is all about. So, the main tools we're going to be using are these three special algebraic identities. Honestly, you should think of them like secret codes for math. Once you know them, you start seeing the hidden structure in all sorts of expressions, and you can play around with them so easily. Let's start by looking at how to use them for expansion. Okay, let's start building that toolkit. We're going to go through these three core identities, one by one, so you can really see how they work and why they're so incredibly reliable.
All right, here's our first identity. It's for a perfect square, specifically a sum. Now, when you see something like a plus b squared, a really common mistake is to think it's just a squared plus b squared, but it's not. You get the square of the first term, a squared, plus the square of the second term, b squared, and this is the really key part, you also get twice their product, that 2ab, right there in the middle. You can't forget that middle term. And you know what? This visual shows you exactly why that middle term has to be there. It's not just some random rule. Look, if you have a big square where each side is a plus b long, what's its total area? Well, it's made up of these four pieces inside. You've got one square that's a by a, so a squared, another little square that's b by b, so b squared, and then you have these two rectangles, and each one of them has an area of a times b. It's just a perfect visual proof of the formula. Okay, let's put it to work with a real example. Say we have x plus 4 squared. First step, just identify your a and b. Here, our a is x and our b is 4. Simple enough. Now we just plug it into the formula. We get x squared plus 2 times x times 4 plus 4 squared. Let's clean that up, and we get our final answer, x squared plus 8x plus 16. See? Super simple. Just follow the pattern. Now, our second identity is pretty much a mirror image of the first one. This time, it's for the square of a difference, a minus b squared. The structure is almost exactly the same, but look closely. There's one tiny but super important change. That middle term is now minus 2ab. That one little sign change is everything. And what's so cool is that the geometry proves it again. Check this out. The area of that light blue square in the middle, that's our a minus b squared, is literally what you have left over after you start with the whole big square, a squared, and then take away those two outer rectangular strips. It works perfectly. Okay, on to our third and final identity, and let me tell you, this one is a real game changer. It's called the difference of two squares. Here's the magic. When you multiply a sum, a plus b, by its matching difference, a minus b, the middle terms, they just completely cancel each other out. Poof! All you're left with is a squared minus b squared. And this is the secret key to that puzzle from the beginning. I love this visual. It's so clever. It shows you how you can take that funky shape that represents a plus b times a minus b and just rearrange the pieces. And when you do, what do you get? A big a square with a little b square chopped right out of the corner. It's a physical demonstration of why the formula works out to be a squared minus b squared. So far, we've been expanding things, right? Which is kind of like taking a machine apart to see all its pieces. Now we're going to learn how to do the exact opposite, factorization. And that's all about putting the pieces back together. And this is the really important thing to get. These identities are a two-way street. See the arrows? They point both ways. That means you can read the formula from left to right to expand an expression, or you can read it from right to left to factorize it. It makes them this incredibly flexible, versatile tool in your math toolbox. Okay, let's just make this crystal clear. Look at the left side, expansion. We start with the brackets, like x plus 3 squared, and we multiply everything out. Now look at the right, factorization. We start with that multiplied out expression, x squared plus 6x plus 9, and we work backwards to put it back into its neat little brackets. They are literally two sides of the same coin. All right, so our foundation is solid now. We've got the complete toolkit,
We know how to expand and how to factorize. So what do you say we put this stuff to work and finally go back and solve that puzzle from the beginning? Remember this thing? 2022 squared minus 2021 squared. A few minutes ago, this probably looked like a huge headache. But now that you have these new tools, does a certain pattern just jump right off the screen at you? How would you even start to tackle this now?
Of course. It's the difference of two squares. It's our a squared minus b squared pattern, where a is 2022 and b is 2021. So let's use that identity backwards. This whole thing becomes a minus b times a plus b. Let's plug in the numbers. That's 2022 minus 2021 times 2022 plus 2021. Well, the first bracket is just 1, and the second is 4043. So what's 1 times 4043? It's 4043. And just like that, we're done. No calculator, no sweat.
But hey, this isn't just for solving big, tricky-looking problems like that one. These identities are awesome for all kinds of mental math tricks. They can help you simplify everyday calculations you might want to do on the fly.
Okay, check out this trick. Say you need to figure out 104 squared in your head. Instead of trying to multiply 104 by 104, which is tough, let's be clever. We can rewrite it as 100 plus 4 squared. And hey, that's our first identity. So it becomes 100 squared plus 2 times 100 times 4 plus 4 squared. Now those are easy numbers to work with, right? That's just 10,000 plus 800 plus 16. Add them up and you get 10,816. We just took a complex calculation and made it super simple.
So now that we've seen all these identities in action, what's the big picture here? What's the main idea you should really take away from all this? You know, when it comes down to it, it's really all about this idea. These identities, they aren't just random rules you have to memorize for a test. Not at all. They represent these beautiful fundamental patterns that are woven into the fabric of mathematics. And when you learn to see those patterns, it gives you this incredible power to take things that look really complex or tedious and make them simple. It unlocks a much deeper, more intuitive feel for how numbers work. And just to leave you with a final thought, here's one last puzzle for you to chew on. Based on everything we've just covered, you have all the tools you need to figure this one out. Just think back to that first identity, the one for a plus b squared. What would have to be true for that middle term to just vanish? Give it some thought. Thanks so much for joining me.